Right. Saying Einstein is talking nonsense is a valid conclusion. When reading Einstein's relativity, it is possible to come to several conclusions. 1. I understand Einstein's relativity, or 2. I don't understand Einstein's relativity. Unfortunately, the many people that come to conclusion 2 often decide they just aren't clever enough to understand Einstein's relativity, but think there must be cleverer people that do. So the type 1 people who believe in Einstein's relativity come to dominate and have their ego boosted, deluding themselves that they are cleverer than type 2 people. This is all psychological flaws in people. For the type 1 people who decide they understand Einstein's relativity, this splits into 2 groups. Type 1a, Einstein's relativity makes sense to them. Type 1b, Einstein's relativity is nonsense. So this is the understanding of Einstein's relativity. You either decide you understand it and it makes sense to you, or you decide you understand it and you understand that it's nonsense. So type 1a people then decide to hurl abuse at type 1b people, calling them crackpots, etc. So type 1a believe they understand Einstein's relativity, and when somebody says Einstein is wrong, they start hurling abuse at them. Now, but what I want to point out, that type 1b conclusion is a perfectly valid conclusion, and from our perspective type 1a people are deluded. So if we go back, type 1a people, they look at type 1b and decide type 1b are crackpots, while we in type 1b look at type 1a and decide those people are deluded. This is not a very fruitful way to communicate. It's just abuse being hurled around. Now, the consequence of enough people realising that type 1b conclusion is correct would mean another revolution of physics equivalent to the Copernican revolution. So at the moment we have type 1a belief dominating, and that's retarding progress in science. And if enough people become type 1b and realise that Einstein is talking nonsense, then we can have a revolution in physics and sort out the mess. So that's what we need. In the pre-Copernican revolution, people were deluded about the nature of physics, and this led after the revolution to the correct physics we now call Newtonian physics. So type 1a people who believe they understand Einstein's relativity, it makes sense to them, they're deluded and they're retarding progress in science, and what we need is their numbers to decrease and type 1b people to increase in numbers, and then we have a revolution in physics. And the correct physics is Newtonian physics. After the revolution that gave us Newtonian physics, there came the counter-revolution, which opposed the correct physics, and it was replaced by Einsteinian physics. So once again, many people have delusions about physics due to this counter-revolution, which gave us Einsteinian physics. We thus then require a counter-revolution to the Einsteinians to get physics back on track. So we need a revolution against Einsteinian physics to get us back to Newtonian physics. Right, I temporarily show you what I mean. And my book, where is it? This is the type of thing I mean. Roger Boscovich, the founder of modern science. It was by Dragoslav Strogovich. I've translated it. And I'm saying this is the unified field theory, and it's 18th century physics. that's the type of evolution we need. We need to get physics back on track with Boscovich. So when I talk about Newtonian physics, the correct physics, Newtonian physics, when I talk about that, I mean Boscovich theory. Right, so what I'm going to be dealing with now is an article, That's Relativity, by Keith Mansfield, and that's recent in February 17th, 2015 at this site. I will then be referring to a talk by Crothers about black holes, and I'll be referring to an article, Did Einstein Not Understand Maths, and a few other sites. So that's where we're going. That's Relativity. It's at the Oxford University Press, and it's written by Keith Mansfield. We go down. Keith Mansfield studied mathematical physics at Trinity College, Cambridge, and is one of OUP's Science Book Commission editors. Okay, so we go back to the top. That's Relativity, and what he's talking about is the science fiction film by Christopher Nolan called Interstellar. And so relativity was used in this film, and he's talking about that, but it's nothing really that much interesting. He had a computer program to model the black hole, which they call Gargantua. Some parts of the movie are a little cringe-worthy, not least the often repeated line, "That's relativity," but there's a reason for the character spelling this out, main reason, because there's so much relativity being used in it. Basically it's a science fiction film with lots of relativity. And this is the interesting bit. Most people don't understand relativity, but they're not alone, and this is what it is. That if you're a person, you look at relativity, most of the time you would decide you don't understand it, and you're not alone. A lot of people come to that. As a science editor, I'm privileged to meet many of the world's most brilliant people. Early in my publishing career, I was befriended by Subra Amen Chandra, after whom the Chandra Space Telescope is now named. Penrose and Hawking built on Chandra's groundbreaking work, for which he received the Nobel Prize. The mathematical theory of black holes is still in print and going strong. So we in the distant community, most of us disagree with what's being said about black holes. So if we go to this little article, video, it's Stephen Crothers, and he's talking about the non-existence of the black hole and the failure of general relativity. And by what that really means, the black hole as described by general relativity doesn't really exist if you're thinking of it in terms of having a singularity. So we have a quick look at this.
Good morning, ladies and gentlemen. I'm very pleased to be invited to be able to address you today on matters concerning general relativity and the non-existence of the black hole. It's also a subject, of course, that's fascinated many people, but it really doesn't have any real sound basis in any science, neither in general relativity or Newtonian theory. So before I get started on it, I'd just like to make a few little comments about these black holes, because there's been some developments in recent times. Like, these black holes seem to be reproducing like rabbits. What we get is, let's go quickly through a whole list of things that we have with black holes. We start off with micro black holes, mini black holes, intermediate black holes, what we might call a regular black hole. Then we've got supermassive black holes. Now recently, they've been talking about ultra supermassive black holes, and I'm waiting with bated breath for the next one. Maybe it'll be a mega ultra supermassive black hole. Well, the proponents of the black hole seem to just add adjectives and think that that makes it, gives it a more scientific validity. Well, adjectives don't do that. That's linguistics, it's not science. So I don't think that that's going to help them. The other thing is, of course, we're starting to get lots of reports of photographs on the internet and in journals and so forth and things. And you get things like, see that part you can't see? Yeah, it's a black hole. The other thing is, see all of those shiny things that shine brighter than stars? Those quasars, yeah, well, they're black holes too. So we now get reports, for example, on quasar 3C279, which is reported as being a black hole. Well, as the previous speaker pointed out, Alton Arp has been speaking about the quasar ejections. So what do we got now? Black holes being ejected from what? These black holes are supposed to be sucking up things, digesting matter and gobbling up the universe. Of course, then we have white holes. They do the opposite. Instead of gobbling up black holes, they vomit matter back into the universe.
So he's pointing out a few of the problems they have in talking about black holes. If you don't see an object, then they call it a black hole, and then if it's very bright, then they're calling it a black hole as well. So they're not really talking about these things very well. But he also then goes on to explain that the maths is really messed up with what they're talking about. So back to this article, this Chandra, who got his Nobel Prize for black holes, we're saying he's messed up the maths quite badly. So next, when visiting Oxford from Chicago in the 1990s, Chandra and his wife would come to my apartment for tea and we'd talk physics and cosmology. And this is the person Keith who's written this article. In one of my favourite memories, he leant across the table and said, "Keith, Einstein never actually understood relativity." So this is an example of another person saying Einstein didn't understand relativity, and he's following it. Quite a bold statement, and remarkably one that Chandra's own brilliance would end up rebutting. But what we have is Chandra believing Einstein did not understand relativity, but we don't agree with Chandra's talk about black holes. And if we go to this lecture on by Stephen Crothers, he explains that the maths which Einstein would have been working from didn't have a singularity, and Einstein would not have believed in black holes from such maths, and suddenly they changed the maths, and from the maths which they now have, they say there is black hole, there is a singularity in a black hole. So you've got this utter confusion in what maths they are talking about. If we now go and look at this article here, right, sorry, that's Einstein realising he's having a big joke at us and sticking his tongue at us. If we go into this article here, Big Bang quantum equation predicts universe has no beginning. This is by Lisa Zigger, and it's reporting about an article which is really a bit of speculation about combining quantum theory with Einstein's general relativity. We read it. The universe may have existed forever according to a new model that applies quantum correction terms to complement Einstein's general theory of general relativity. The model may also account for dark matter and dark energy, resolving multiple problems at once. So what they're trying to do is combine quantum theory with general relativity, and when they've dealt with general relativity in the past, they've been talking about a black hole, been talking about a Big Bang with a singularity and hence a beginning to time, and a black hole would sort of like mirror that. You would have a singularity, same as the Big Bang would have a singularity, but when they're trying to add quantum theory to it, they are disposing of the singularity in this bit of speculation. So this is an example of suddenly them trying to change the maths again. Sort of like a bodge. Einstein's general relativity, so it has a singularity for Big Bang and for a black hole, so say. And if they're going to add quantum theory to it, they then want to get rid of that sort of thing. So they're just bodging it, basically. So Chandra's understanding of black holes, so say believing Einstein was wrong, he's probably all messed up on that particular thing. So Einstein's saying something else, and he's believing something else about black holes. So it carries on. Space is big, mind-boggling. So you start to think about it, and we only know how big it because of Chandra, which is not quite right. It's Hubble before Chandra worked out space was big, that galaxies are out there, and so forth. So it goes on. And why Chandra told me Einstein was wrong was because of something Einstein himself called his greatest mistake. So presumably what he's saying there is tying into what was said up here about he believing that Einstein didn't understand relativity. When relativity was first conceived, it was before Edwin Hubble, after whom another space telescope was named, had discovered space itself was expanding. So that's the way they talk about it. They talk about space expanding. Seeing that the stable solution of the equations would inevitably mean the collapse of everything in the universe into some big crunch, Einstein devised the cosmological constant to prevent this from happening, an anti-gravitational force to maintain the presumed status quo. Once Hubble released his findings, Einstein felt he had made a dreadful error, as did most astrophysics. However, the discovery of dark energy has changed all that, and Einstein's greatest mistake could prove an accidental triumph. So what they're talking about is the well-known thing about Einstein and the cosmological constant. Einstein added it to his equations and then decided he shouldn't have added it to his equations, and now subsequently after Einstein they're thinking about putting it back again. So they're playing around with the equations. 1 minute add it, next minute take it away, next minute add it back again. And when they're talking about that, they're thinking, oh, Einstein didn't understand relativity. And they try to cover it up a bit here by saying, of course Chandra knew Einstein understood relativity better than anybody on the planet, but it frustrates me that many people have such little grasp of this most beautiful and brilliant temple of science. Right, so he's just going on to a diversion here, the writer Keith, and he's saying, oh, after this bit of information about Einstein Einstein never actually understood relativity. After that, he's trying to cover it up with a bit of a bluff. It's all playing around with the maths a bit. So here is the bloke again. I think he knew he messed us up. And I dealt with that. So we get to this. I thought this was interesting, this article, The Suppression of Inconvenient Facts in Physics. And the person writing this at this website is pointing out, he's quoting a person, number one, let's see who that is, quoting a person, Brian Martin, from Stamping Out Dissent in Newsweek, 26th of April 1993. Go back to it. So this quote from him is, textbooks present science as a noble search for truth in which progress depends on questioning established ideas. But for many scientists this is a cruel myth. They know from bitter experience that disagreeing with a dominant view is dangerous, especially when that view is backed by powerful interest groups. And in the case of Einstein, the powerful interest groups are people who worship Einstein as their hero. Call it suppression of intellectual dissent. So we do suppression. There's people here worshipping Einstein and they're trying to suppress dissent with that. The usual pattern is that someone does research or speaks out in a way that threatens a powerful interest group, typically a government, industry or professional body. Professional body would be the people who believe in Einstein. As a result, representatives of that group attack the critic's ideas or the critic personally by censoring writing, blocking publications, denying appointments or promotions, withdrawing research grants, taking legal actions, harassing, blacklisting and spreading rumours. So if we go back to here, so the type of people who decide they understand Einstein's relativity split into two groups. Type 1a, they think Einstein's relativity makes sense, and type 1b, they think Einstein's relativity is nonsense. And so this type of person is trying to block any dissent against their view. So they're trying to block any papers being published. They can't completely do it, but they do manage to block a lot of it. And this is what's being pointed out. This person here is sort of interesting. This is an old article in 1996, and it's what Ed and Taylor is saying, a call for give and take. As a former editor of a physics educational journal and co-author of 2 relativity texts, I have had a lot of contact with what your article, this is what Edward Taylor is saying, and he's referring to an article by B. Goodman and the scientist in May 1995, calls dissident scientists, many of whom attack special relativity. So this is what I'm talking about, the dissidents. Type 1b people are dissidents, they're attacking Einstein's relativity, while the mainstream is trying to impose it upon us. So the dissidents. Many calls dissident scientists, many of whom attack special relativity. In my experience, most are extremely intelligent and inventive. So, go back. So he's saying these people are intelligent and inventive, and we are of the opinion that Einstein's talking nonsense. We're not stupid, we are clever, and so hence our conclusion is valid. It's a valid sort of conclusion to get. Their arguments are ingenious, and any errors are often difficult to find. So we're ingenious, and if we make mistakes, then often they're difficult to find. We're talking quite a lot of sense. Still, there are 2 characteristics that I have found in many dissidents with whom I'm communicated. Right. One of the characteristics is isolation. Most dissidents are isolated to some extent, but now with the internet we're not being so isolated. Go down. We're now forming into a group. It is heartening that the dissidents are apparently developing a group identity. That's correct, we're forming now a group. Your article leaves the impression that at least this cooperation is largely political, a united effort to obtain public hearing for their ideas. If this can be extended to an internal dialogue about the theories themselves, everyone will benefit. Could an editor allow such a group to select, say, 1 article for publication per issue? If the article was so identified, it might transcend the usual barriers while providing a less biased hearing for the dissident theory. Right or wrong, the published theory could provide a monthly challenge to young scientists to question or validate what they are being taught by their elders. So, Edward Taylor, Department of Physics, Boston, this is some time ago now, is asking for them to consider dissident physics. At the moment they are trying to block it, as pointed out by this article. They try to block dissident physics. No Big Bang. Einstein poking his tongue at us. Right, Stephen Colours. And so that's it for the moment. The next thing I want to be dealing with is this sort of person. It's Peter Beckman. That'll be what I'll be getting on to next. Peter Beckman. Go here. Peter Beckman is an example of a dissident sort of scientist. Sadly, he's passed away now, died in 1993. He was a professor of electrical engineering, and the important thing, later in his life he challenged Albert Einstein's theory of relativity and other accepted theories in modern physics. So he's dissenting against Einstein's relativity, and I want to briefly touch on that. So that's it for the moment for this part, and I'll be going on to Dr. Peter Beckman. Well, actually, this is what this person is saying about Peter Beckman. So I'll pause for a moment.